Hello friends, सबको नमस्ते. So today in this video we will create a apple, banana, orange detection using a YOLO model. Okay, for that, let me first download my zip file from my Google Drive to this Google Colab. For that, I will share the link. It's taking time. Please wait. Copy this link and paste it here and keep this part only. Till this only you have to keep it and just paste it. You will link your Google Drive, or you can say you can download your zip file in your Google Colab. This is your file name and just download the zip file. Just run the cell. Your dataset zip file will get downloaded. Then you have to unzip it. Make sure that the file name will be same, just here and here. You can see this is a zip file and this is your dataset. It contains 3 folder: test, train, and well. And this is a YAML file. Okay, and you can see that I myself created the YAML file, because in most of the cases when I downloaded a dataset, there is a chances that YAML file does not get by default. Okay, so I had created myself. This is the path of my dataset. This is a train directory. This is well. This is test, and number of classes which we have is 3: apple, orange, and banana. And same way I had given the name. Okay, and this way you can create the YAML file. Just give the name of your YAML file apo.yml in a write mode, then file, then which data means this data I want to be inserted in this file. Okay, so this way your YAML file that will create it. May refresh it and you can see this way. And what is the use of this default flow style? Let me show you. If suppose I will not use false here and just use true here. Okay, now I will run this. See the result. Let me refresh it. See the result. Now result is saved in this manner, but we do not want this this type of data, or you can say this architecture of the data, because we want to train the YOLO model, and the architecture of the data to in the YAML file should be this way. Okay, so to get this type of YAML file, we have to use false here. Okay, now let me run this cell again. Now let me see this. We want this type of architecture of the data. Now this is Ultralytics, from which we can download the YOLO model. Okay, let me run it. Now here we import the YOLO model, and the model which we are using is YOLO V8 AM. Okay, you can see this. YOLO V8 and S, M, L, X. There are many YOLO model of 8 version. Okay, and the difference in these is parameters, flop, speed CPU. These are the difference between them. And most of the cases we look for the number of parameters, and the YOLO model V8AM is having a 25.9 parameters. Okay, million parameters. Now we will here the definition of YOLO model is created. Now we have to give the model.train. With this, we in attribute data we have to give the YAML directory, or you can say file name, through which YOLO model during training recognize or get knowledge that on which folder, in which folder the training data is there, test data is there, validation data is there. Okay, and number of epoch we want 50, but this time I just want 5 to show you how your model is training. But I already have a wait file which is 250 epoch, so I will show you a result of that. And image size will be 640. You can see this. image size is 640. Okay. Now batch means 8. Batch 8 means when the training data set or a number of images is divided into batches, how many number of images you want in one batch. I want 8 images in one batch. And this is ABO YOLOv8. This is a folder name. When you will run this cell, uh, the the run folder will get created automatically. Inside that, detect folder is created, and inside that another folder is created, and that folder name will be ABO YOLOv8. And inside that ABO YOLOv8, best.pt and last.pt, two wait file will be there, which is of your training, and means best pt means best wait file during training will get saved. Save true, you want to save the wait file. And save period -1 means we do not want to save wait file of every epoch. We only want to save the best epoch. Okay. Now patience 20 means early stopping, means it would look for 20 epoch. After 20 epoch, if there is no improvement in the accuracy or in a loss, so it will stop the training and the best model will get saved. Validation true, since you can see that validation, we have a validation folder, so we can use validation true. And in my case, in most of the cases, or I can say when I downloaded a data set from the web pages, in most of the data set, validation folder is not there, so at that time you can use validation false. It will does not throw any error. Now let me run this cell. So this way training will get started. See, epoch 1 5, epoch 1 training is get started. And what I'm talking about, let me refresh it. See this run folder, uh, inside that run detect, and inside that avio YOLOv8, and inside that you will see that there is a wait folder, and inside the wait folder you will get best and last wait files. This time it is not showing because first epoch is now going on. So let me show you afterwards. So this is a drawing boxes, means when I will use that model uh, during testing time, so I have to draw the bounding box around the detections. So this is a function which I will use. This is we are using image as a parameter, bounding box details as a labels, means whether it is a apple, banana, orange, or a color samples, means different different bounding box should be displayed with different colors. That's why color samples. So image, first we will make a image copy of the image. After that, using this box, we will map the xmin, ymin, and xmax and ymax values from this box variable. Okay, and you can know that xmin and ymin is the top left corner of the bounding box, and xmax and ymax are the bottom right corners of the bounding box. Now we randomly choose the color sample. After that, first we will just create the rectangle around the detection using this bounding box details, xmin, ymin. Okay, and just a color which we have selected, and this is a thickness. Now other, we want to put the you can say label below. You want to put the label below at the top, at the bottom left corner. uh, Let me show you bounding box. Oh, see this. So I want to display this label, this bicycle label, at this corner. At this corner means bottom left corner down. Okay, at a down of this. So how I can display? You can see this. Just pass the image, then the label which we want to display, and this is axmin. You can see this xmin is here, but here its value also same. So xmin and ymax. You can see this ymax is here, bottom right, and here the ymax value is same, because one thing I want to tell you that y value in the images or during model in the training or using CP2 in all these things, 00 value for the by start from this bottom, top, not bottom, top left corner. From top left corner, 00 value start for the y and x both. So for this purpose, y max value is here. Now I want to display some below this corner. So I have add some 40 value pixels value, 40 pixel value. This is the font. This is a thickness of the. This is the size of the label. This is a color. This is a thickness. This is a line. Okay. Now here we. Now here I am. This is not required. This is, and here just we return the image with bounding boxes. Okay, so everything is done. Now here we first import the YOLO, then the CP2, then Matplotlib, then random, then yours. Now first we have to upload the model which we have trained. You can see that we are from where we are uploading. We are uploading from run, detect, then the folder which we have decided name, then the weight file, and you can see this inside the weight file, two weight file there, best and last, and I want to use west here. Okay, now text image directory, you can see this is image and this is a test directory, and inside a test directory this is two folders, image and labels. And one more thing I want to tell you, that during training with the YOLO models, the architecture of the dataset should be this way only: test, train, validation, and images and labels. Okay, so this is the architecture of the folders during training with the YOLO models. Now here images, this is not dataset, will not come here. This this folder is not there. Test images, this is a color sample which I have decided, means I want to display each bounding box with different colors. So that's why I have decided these colors, and inside this color sample I will decide one color. Now first I want to make the list of all the test images list. So I have used OS list directory. And for the prediction, you can see this is a figure which represent the entire plot, and axis is basically used for retrieving or iterating over the each subplot. Here this during this time, this is in this line here, ax is in a 2D format. When I will use this ax or reval, it is in 1D format, because after converting into a 1D format, the iteration toward the subplots become easy, and we use plot the subplots, 4 rows, 4 columns, then figure size will be 16 by 16. So now 4 by so means 16 iteration, means 16 subplots. So that's why I will iterate over 16 times. I will first randomly select the image name from the image files which we have created here, which we have created image file list. Inside this, to generate the directory of the image file, we have to use os.path join. That's in which we first pass the image test image directory. Means here means the compiler will went to the image till images folder. Inside that images folder, which image we have to select, that image name we have to give, that is this. After that, the image directory get created, and just we have to read this image. And you can see that here I am not passing the image, here I am passing the image path, but there is no difference. Either you will pass image path or image, there is no change, no error will be there. Okay, now what is the means of 0 here? You can see that I am passing only one image. So to get the information related to that only one image, I have to use 0 only. Okay, you can see there's get first result one index. After that, now here why I am using for loop. This is because it might be possible there that in one image multiple detection will be there. I repeat my line, that it might be possible that in one image multiple detection is there, multiple bounding box will be there. So to have to get to draw each bounding box, I have to iterate over this result dot boxes, and you can see this result dot box is a dictionary. I will not tell you. Okay. Inside the result box, for the first bounding box, all detail will be all detail will be stored in this box. If I have talk about first iteration, to get the x by x by, I will use box dot x by x by 0 because only one image will be there. Now to get the class ID, I will use box dot class ID class, and by using this class ID, model dot name give me label of that, means whether it is orange, apple or banana. After that, I will just pass that old this whole detail into the draw boxes, and the compile will bend to up. Okay. After that, I will you can see this image is read in the CB2 format, uh, and here also image is read in the CB2 format. Okay. And you all know that image read by the CB2 is in BGR format, so I have to convert that into RGB, so that I have here use CB3 color to convert that into from BGR to RGB, and thus we have to display this image access false. Okay, so I think so training is over. Your epoch 5 epochs training is cat over. So let me first show you how this training with 5 epoch model gave result. Okay, let me show you the result of this results dot boxes, what is showing with only first iteration. See this result.boxes is like this. You can see this class is a tensor format with list, confidence list, data list, id none, isotrack, order shape. You can see the bounding box details is in a for format, x by wh, x by whn, x by x by x by x by. Okay, and what we want this one x by x by format. So how you can now understand how we are retrieving the information from this box variable, box dot x by access, box dot classes, and 0 you only know that why we are putting 0 here, because we are using only one image for the detection. Now let me run this whole part for 16 iteration, and let me show what is the mistake here now. Draw boxes is not defined. I think we do not run this cell. Now let me run this. See the result at Apple, but you can see the detection is not that clear or not that much good. So if we have to achieve the better accuracy, you have to increase the epoch. Now let me upload my model, which is trained on 50 epochs. Okay, this is a model which is trained on 50 epochs. Let me upload this and use this. Let me copy this name, and now we are using the model which is trained on 50 epoch. Okay, so let me come back when it gets uploaded. So let me run this cell. Now you can see the result of the model which is trained on 50 epochs. Okay, see this. It's showing better accuracy than the model which is trained on only 5 epochs. Orange, apple, orange, banana. Okay, it's sometimes missing, but it's better than the model which is trained on only 5 epoch. Okay, so you can increase the epoch and increase the accuracy, and you can download that model and you can use it anywhere. So this is explanation. So please like, share, and subscribe. Thanks to all.